Hello there. My name is Rene Leal, and this is my presentation, The Age of Antiviral Resistance. When I started this project, I actually wanted to study about antibiotics. But while I was studying them, I found out about the problems that they're having, where lots of biotics are having resistance to them. And I was thinking, can there be other medicines that are like that? And I found out about antivirals, and so I wanted to share my concerns about them with you. Thank you. So before we talk about antiviral medications, we have to talk about viruses first. So viruses themselves, they can be treated with antivirals. They're highly contagious, and because of their easy to manipulate structure, they're highly unstable and they mutate very easily. They mainly affect the respiratory systems in people and replicate there. And there's three main types of influenza, ranging from A to C in that order of severity. We'll be talking about influenza A here because that's the one that transmits between humans and animals. So the way influenza attacks a cell is what you'll have is a healthy cell here, and they'll have these proteins that link up and communicate with the virus proteins, and you'll have this communication where it'll allow the cell to virus link up to happen. You will also have the communication of pH so that the RNA can flow through freely, and then some other proteins like the M2 channel allows it to cut off from this healthy cell and break off and infect another healthy cell. And that's how you'll see this kind of exponential overnight taking over of the body by like a few virus cells. Now, what this means in humans is you'll have a runny nose, coughing, and then some extreme cases. Let's say there's some mucus buildup, and then you get this flu too inside of your lungs. Well, then they might have a pressure problem, and they might rupture. And there's also exhaustion and death in the worst case scenarios. This general effect on the population, though, means that it's just highly common during the winter. 5 to 30% get the flu yearly, and 5 to 40,000 people die to the flu every year, just in the U.S. So, to my actual presentation, what could possibly happen? It's just the flu. We get them every year. But I mean, really looking at it closely, there's so much that could happen. It could be such a problem for us, and I think it's really important that we dive into the general problems we may face. So, in general, this is how a flu is supposed to work. You can ignore the math here. This is just if someone needs to check my math if they want to. But what you see is this gradual growth of the infection slowly, and then eventually, when you hit a sizable exponential number, there's just be an explosion of cases. And what this does to the healthcare system is it overloads it so that now hospitals are full of people getting treated with the flu when there's other important but not in the spotlight treatments needed. And so even though only, let's say here, 1% of people who get infected die, there's a whole bunch more tacked on of people who weren't able to get their life-saving treatments because there's a dangerous flu going on in the hospital that's treating them. So in reality, you'll see a curve like this mostly, where the infection rate is spread out because at the beginning there might be a normal infection spread rate, uh, but as people take notice and governments take notice, they'll try to lower the R naught, the transmission rate, and so you won't have this general overbearance of the healthcare system. Again, numbers here if you want to check them. The way governments and people do this is they issue vaccines. This is done preemptively every winter or fall to get our yearly flu vaccines to limit the number of flus going around and spreading. In extreme cases, like now and in the Spanish flu era, St. Louis practiced social distancing, and that dramatically lowered their mortality and spread rate during the first crust of the Spanish flu in 1918. And now, more modernly, to prevent entire or small pandemics in local communities, they'll issue high risk people like the elderly who live in group homes antiviral medication. And what this does is it lowers the spread rate of the infection by making it impossible for the flu to act normally and infect cells. I'll explain that in a minute. But the history of antiviral medication. The beginnings of the first breakthrough in the area of antivirals was in 1959 with the development of idoxuridine, which was found to combat herpes simplex virus. This was one of the first times where it was found that a medication was directly antagonizing a virus in a tangible way. Fun fact about this: it wasn't actually meant to cure herpes. It was supposed to be a drug to combat cancer, but during the lab test, they found that it combated herpes, and so they just went along with it. Now, the way that these antiviral medications work is it blocks proteins from communicating effectively. So, for example, you have your virus cell here, and it has, let's say it's the M2 proton channel here. Okay. And this is supposed to communicate with this communicates with the healthy cell here. Oh. Technical difficulties like that. Okay, so it communicates with the healthy cell here, which has its partner M2 proton channel that communicates here. So what the M2 proton channel is supposed to do is it regulates the pH so that the RNA from this virus cell can go into this healthy cell and start transcripting and duplicating inside. But what a medication like amantadine here will stop the communication and not allow this pH to become or change to allow RNA strands inside to communicate to the healthy cell. Now, the field has been slow to develop safe therapies because it's very difficult to isolate these proteins that communicate with each other and to create effective drugs that only work here between this cell to virus relationship and doesn't affect something way off in the nervous or general body systems. Now, the therapies that have already been developed, they're already starting to show failure, which is very bad, but it's not unexpected when we really think about the bigger picture right now. Now, the problem with antivirals in general is that we have a very ineffective healthcare system to use them. Healthcare is proactive; it's not really preventative. So what will happen is these antivirals, they have to be prescribed within 24 or 48 hours of the first signs of getting them, because these cells replicate and spread within your body at a logarithmic rate. There's not a lot of easy ways to stop the spread once it's covered up most of your body and you're just oozing with it, right? If you grab an antiviral, sure, it might stop the communication within you, but you're a danger to the community at that point. And there's really not any reason to give you an antiviral medication, because since there's so many virus cells inside of you and they're all replicating at this very large rate, if they give you the medication and let's say by some miracle it kills 99% of all the virus cells inside of you, even though they'd be gone naturally in 2 days, what you'll have is you'll have that 1% that replicated to and is immune to that medication. And so now, even though you're healthy by 1 day early, you have you were spreading this disease this virus that's resistant to antivirals, and that's horrible for like a community. Let's say uh, my grandma in a group in a nursing home. If she got that and she was spreading it, well, great. She's okay, I guess. But now she's infected half the bingo hall. It's real bad. Imagine that on a world scale. That would be horrible. And then there's also the tremendous cost and risk with developing antiviral medications. Because there have been only maybe 3 or 4 breakthroughs with antiviral medications. Because it's a very simple medication to give, but there's just no, uh, financially, there's no upside to developing these antiviral medications because it's a one and done, right? Because of the way that these viruses mutate and they spread exponentially. Maybe let's say a large scale pandemic happens in some city, and some company makes a great antiviral that attacks that strain. Well, that's it. That's the only time they're going to be able to sell that uh, antiviral medication, because if people aren't safe and aren't being smart about how and when they drink these antiviral medications, you will just 100% end up with a new strain that's resistant to the antiviral medication. And all the research and development gone into this medication would be worth nothing. So it's not really high on the development chart. So this is where my personal theory comes in. This is my personal theory of entropy and what's about to happen in the modern age. So I think there's a general lack of information about the healthcare system among people. Everyone thinks that we can get grandpa on the moon. I should be able to get a bypass surgery, right? But there's always been this disconnect, it seems, because even like during the Greeks and Romans, if you were smart and you were socially acceptable, you went into math. That was the glory science to do. And so, because of that, healthcare and anatomy in general was put on the sideline for much of human history. And so, all the advancements you see today are late in comparison to the rest of our society, more or less, because there's just been this general brain drain over the years of getting uh, medication and development out there. So what you could see is maybe one day or maybe today, who knows? But you'll see a pandemic where where it gets really out of hand, and we need antiviral medications. Let's say during the replication process, there's some kind of fatal thing that happens to a lot of us. Well, one of these days we're gonna look at antiviral medications and we're gonna say that's it. That's the one we need to combat this pandemic. And so what you'll see is maybe over the course of a year, some country or company develops enough medication for everyone on the planet, and 90% of the planet maybe gets cured or isn't fatally killed from the infection because of this antiviral medication, and it'll be seen as like the holy grail. And so maybe we start adopting this more and more and more frequently. We use them like antibiotics, and then we'll end up in a situation where we've accidentally incentivized the creation and proliferation of hundreds of new influenza types. And if we get a cocktail of those, we don't have the resources or the time to combat that many pandemics at once. And so we might see a general staggering of the healthcare industry in its combat with the flu. So I really don't see how this could be an effective treatment over time. You can see this with the local vulnerabilities. Countries to country, it takes forever to talk to each other. It's virus simplicity, easy to manipulate. Longevity of an epidemic, you can have one epidemic at the beginning and then it's up to two. Mm. And there's economic reasons too. Anyway, these are my references. Thank you for listening to my presentation. And I want to give a huge shout out to Dr. Baltazar at Sugar Land Vein Clinics for helping me out and letting me mentor. He's been awesome, and thank you, sir. Thank you.